Now that we know how to find the volume of prisms and of cylinders, it's time to tackle the pyramids and the cones. Take a look at these. This prism is supposed to have the exact same base area as the pyramid does. So these are equal or congruent bases, and the height of this prism is also supposed to show that it's the same height of the pyramid. We know how to find the volume of the prism. It's the base area times the height. But clearly we wouldn't do the same thing on the pyramid, because this pyramid, since it tapers, would have a smaller volume. The question we have to answer is how much smaller. How many of these pyramids would it take to fill up this prism? What do you think? And I want you to write down a guess. Is it 2, 3, 4, 4.5, whatever. But let's take a guess and then watch this quick video to find out the answer. All right, I think that was pretty clear. This is going to take 3 of these to equal that. So it would be 1/3 of the base area times the height of the pyramid. That's how we find our volume of a pyramid. So in our formula, we're going to be using volume equals 1/3 of the base area times by the height of the pyramid. Okay, so we're going to find the base area, and we're going to also calculate the height. Now, something important to note, that height is not slant height like when we did area. This is our altitude type of height that you're going to want. And don't forget the 1/3, you got the volume. Here's an example. And we're going to walk through the steps like we always have. So first, let's identify what it is. Look at the base. Looks like it's a rectangle. Rectangular pyramid. And while we're here, let's note what the height of that pyramid is. This is a height, that pyramid is 12 miles high. 12 miles, wow, must be a mountain. All right, now that we've got that, what are we looking for? We're looking for volume, so we need the formula. Find the volume of a pyramid with 1/3 base area times the height, which leads us now to our third step. We need to figure out what the base area is. Since this is a rectangle, the area of a rectangle is just the base times the height of it, or length times width, however you want to do it. So that's 10 miles by 7 miles. We'll just plug those numbers in. 10 times 7 is going to give us 70 for our base area. And now we're on our final step. We're ready to go plug those numbers into our final formula, bringing down the 1/3, 70 for base area, and back up here we got our height of 12. So our final calculation here looks like 280 cubic miles. It's a pretty big mountain. Okay, let's walk through those steps another time here. Now this time, as we identify it, it looks like it's got a hexagon base. So it's a hexagonal pyramid. And take a look, what is the height of our pyramid in this case? Straight through the center, straight through the pyramid, 11 kilometers. This thing's huge too. Who is coming up with these examples? Okay, we still want volume, so let's write down our formula on our pyramid volume, 1/3 the base area times the height. And now, once again, we are on that third step where we get to figure out the base area. Now with this one, I think it's smart to draw the hexagon. I have technology to help me, but get a sketch of a good regular hexagon that you can use. And let's put down what we know about this hexagon. All that we're told about it is that this side here is 8 kilometers, other than the fact that it's regular, so they're all 8 kilometers. 8 kilometers on every side. And that means that our formula is that half your paw formula, half of the perimeter times the apothem. So we got a couple of things we have to figure out. Perimeter's not too hard, we can do that. Perimeter would just be that 6 sides times 8, so 48 for the perimeter. We can go ahead and put that in. But the apothem, we don't know that, it's not given to us. Let's just draw a picture here. So coming from the center, I want to hit the side at a right angle. And remember, this is 8 along the bottom, so I've got now 4 on my half of that. And I'm going to finish off my triangle there. We've seen hexagons a lot. You should know by now that this is a 30-degree angle here in my triangle, so I'm using a 30, 60, 90 triangle. I know the short side, so I should be able to get the apothem pretty easy just by timesing by radical 3. So 4 radical 3 is my apothem number. And I'm going to put that into my formula. And keeping it in terms of radical 3 to keep everything nice and precise, this half of 48 times 4 is just going to give me 96. So 96 radical 3 for the base area. All right, we are in the home stretch. Now all we got to do is just come plug it in. So for our volume, we just figured out our base area is 96 radical 3. And we made note of our height just back there is 11. So let's get it cranked out. Again, I'm going to keep it in terms of radical 3 to stay exact. Let's take a third of 96 and times that by 11 for a grand total of 352 radical 3. And check your units, that's going to be cubic kilometers. Okay, step by step, and it's not too bad. We can even apply those steps when we don't have a picture. Let's read through this and then let's take it step by step. A triangular pyramid with a right triangle base with a leg of 12 centimeters and a hypotenuse of 13 centimeters has a volume of 85 cubic centimeters, and find the height of the pyramid. All right, well, in our first step, we have to identify what we have. In our description, we have a triangular pyramid. So I'm just going to make a note down here. The triangular pyramid. And as we finish off this step, we want to know the height of the pyramid. So as we look for that, notice that finding the height of the pyramid is our question. All right, let's now go to step 2. In step 2, I need to get a formula. What am I looking for? I want to know about volume here. So I'm going to use my volume formula. 1/3 the base area times the height. And then I get to analyze that base. Excellent. All right, well, let's highlight what we know about the base here. We are told that it's a right triangle. It's got a leg of 12 centimeters and a hypotenuse of 13. Let's just try to sketch that out. Okay, so here's my awesome right triangle. One leg is 12. We'll put that here at the bottom, and 13 on the hypotenuse. Of course, we need to know the base area, which is 1/2 of the base length times the height. I don't have the height, but I can get it pretty easy. I notice this is a 5, 12, 13 Pythagorean triple, so that's my height. And plugging in, I can get the area. So 1/2 of the base times the height means 1/2 of 12 times 5, which comes out to be 30. Okay, we are ready to wrap it up. So into our formula we go. 1/3 of my base area, which is 30, times the height, which I don't know. All right, how am I going to complete this? Well, I need to plug in what my volume was. Back up here, the volume was 85 centimeters, so I'm going to put that in the volume spot, and let's do the math. All right, bringing the 85 down, it looks like 1/3 of 30. That's just 10. So now I get to divide by 10, and I can get my height. Get the ninjas in there, and the height would be 8.5 with units of centimeters. 8.5 centimeters on height. So we can do it even without a picture. Just follow the steps and you're good to go. Okay, as we wrap up this lesson, let's finish it off with cones. Now, cones are just like pyramids. We're going to find a base area, and we're also going to use the height. Notice the height is right here. It's not slant height, it's the regular altitude height. But because the base is always a circle, it's going to be just a pi r squared as we figure out the area. And that's why when you look at formula sheets, you usually just see cones written as 1/3 of pi r squared times the height. The base area is always pi r squared. That makes it easier to work with the formula even. Let me show you here. So our volume formula for this cone is 1/3 of pi r squared times the height, and we should just be able to plug things in. So let's bring a lot of this down. All right, what do you notice over here as you look for the radius? They gave you the whole diameter, so split that in half and use 3 for your radius. And as far as the height, they gave that to us in 10. So those are just going straight into the formula, and then we get to do the math. Let's take 1/3 of, this will be 9 times 10. So 1/3 of 9 times 10 is going to be 30. Bring down the pi, I get 30 pi cubic yards. This one looks a little more interesting. Let's read through it. Caitlin made a teepee for a class project, and her teepee had a diameter of 6 feet. I don't see that on here. Diameter is 6 feet. I know I need radius, so I'm going to put radius in there as 3 feet. And the angle the side of the teepee made with the ground is 65 degrees, which I do see here. What is the volume of the teepee? Well, the teepee is a cone, so we can use our volume of a cone formula. I'm going to get that written down again. And then let's just get stuff plugged in. All right, now I know the radius is 3 feet, but here is an example where they didn't tell us the height. We have to figure it out on our own. So I think you can see we're going to have to use that 65-degree angle. Let me just draw the triangle out we're going to use. This is going to be a trigonometry problem. With 65 as our angle of perspective, the height would be the opposite side. And I know this is 3 feet here adjacent to it, so we've got opposite and adjacent, or a tangent ratio. Using the tangent of 65 degrees is equal to the height over 3. When I cross multiply that, I get 3 times the tangent of 65, and that's equal to my height. So I'm going to keep it just like that and put that into my formula. Up here we go, 3 times the tangent of 65 for height. All right, when it comes to calculating that, there's a few things I'm just going to bring down. Pi is going to come down, tangent of 65 is going to come down, and I'll worry about those in a minute. But let's get all these other numbers taken care of. What's 1/3 of 3 squared times 3? Well, 1/3 of 3 is just 1. That'll cancel, so all I've got is 3 squared. 3 squared is 9. Give that a shot. Now grab your calculator, and everybody should do this because this is a little complicated, so see if you can get this answer. And let's put that into the calculator as 9 times pi times the tangent of 65. Hit equals on that, and I get 60.6 is my to the nearest 10th answer. And let's see, the units on this were feet, so let's put cubic feet as our volume. All right, that one was kind of cool, a little bit of a challenge for us.